when we mention the Bermuda Triangle, we find that the line between fantasy and reality is surprisingly blurred. In our previous video, we only provided an introduction. But those sensational disappearance cases, however mysterious, have rarely caught the public's attention. This mystery, which has piqued the curiosity of an entire generation, leads us to wonder, has the answer truly been uncovered? In this video, we will do our best to explore the stories beneath this ocean area from a scientific perspective. Hello everyone. Those who believe that the Bermuda Triangle is a death trap might not be entirely wrong. This area of the ocean is indeed very complex, with large swells, deep water depressions, a complex system of ocean currents, and atmospheric circulation. Now let's dive deeper into all of this. First, let's start by discussing the seafloor. The seabed structure of the Bermuda Triangle has been thoroughly studied. Scientists even know about the seabed conditions several kilometers below. Through studies of the Florida Shelf, the Bahamas, and extensive drilling and geophysical research in the Bermuda region, we have learned that the seabed terrain here is highly varied, including shoals, continental slopes, margins, central plateaus, deep-sea canyons, deep-sea plains, and trenches. This diversity is extremely rare in a relatively small ocean area. Scientists, through large-scale seabed topography measurements, have roughly divided the Bermuda Triangle area into two parts, the southern and the northern sections. The southern section includes the Florida Shelf, Bahama Shoals, Straits, and the Puerto Rico Trench. The seabed morphology shows extensive shoals interspersed with striped structures, alternating with straits and deep ocean areas, resembling a complexly woven carpet. In contrast, the northern section is relatively calm with a more uniform seabed topography. The broad continental shelf in the north and east transitions into deep-sea plains, and some underwater mountain ranges and larger Bermuda platforms appear. Although calling them mountains might be an exaggeration, these underwater uplifts in the northern and eastern regions indeed form several prominent groups. Their heights range from 150 to 200 meters, and by land standards, they wouldn't even be considered mountains, but rather hills. Viewed from above, the round or oval contours of these small hills are clearly visible, with slopes ranging between 10 to 30 degrees and base diameters varying from a few kilometers to tens of kilometers. The number of underwater mountains in the Atlantic is far fewer than in the Pacific. The Pacific has about 10,000 underwater mountains, while the Atlantic seabed has only about 600. This isn't because the Atlantic is smaller in scale, but because the Pacific's geology is more diverse. Even so, in the Atlantic, there are some areas where the seabed morphology is quite unusual. Most of these fascinating structures are found in the Bermuda area. The name of the Bermuda Islands comes from the largest underwater mountain range here. Some underwater mountains rise alone from the seabed, while others appear in groups. The primary material of these underwater mountains is basalt, but they are difficult to see due to being covered by limestone deposits. Deep below, a unique geological structure lies hidden, a limestone platform composed of limestone deposits up to 6 kilometers thick. These deposits are almost entirely made up of ancient, microscopic organisms remains. Imagine millions of years of microorganism remains piled up together, forming the solid limestone layers we see today, recording traces of life from Earth's ancient past. Besides the limestone platform, Bermuda is also known for having the northernmost coral reefs on Earth. For hundreds of millions of years, the natural conditions here have remained almost unchanged, allowing these coral reefs to survive and thrive. Despite the fascinating geological structures here, scientists have still not reached a consensus on the origin of Bermuda. In 2019, a group of international geologists published an article in the journal Nature proposing that Bermuda might have been formed by an extremely rare type of volcanic activity. This volcanic activity mechanism had never been studied before, but it might also have contributed to the formation of other volcanic islands worldwide. Normally, volcanoes form at the boundaries where tectonic plates separate, as seen clearly at mid-ocean ridges, like the Mid-Atlantic Ridge. Additionally, volcanoes can be found in subduction zones. like along the coast of Japan, where one tectonic plate sinks beneath another, causing magma to rise and form volcanoes. Another mechanism for volcano formation is the continuous vertical flow of magma rising from deep within the mantle, gradually melting the overlying lithospheric plates. This process formed the Hawaiian Islands and continues to this day. Imagine a massive fountain of magma continuously spewing from the depths of the earth, day after day, building magnificent volcanic islands. For many years, it was believed that the Bermuda Islands were formed by ancient volcanoes triggered by a mantle plume. This sounds reasonable because a stable mantle plume has indeed been observed in Bermuda. However, this theory has a significant flaw. Mantle plumes usually leave behind a characteristic chain of islands, much like the Hawaiian Islands. This is because the Earth's crust moves slowly over a stable vertical magma flow, producing this phenomenon. Moreover, Bermuda currently shows no signs of volcanic activity influenced by such magma flows. So how exactly were the Bermuda Islands formed? To resolve these inconsistencies, geologists conducted additional analyses on a rock core collected from Bermuda in 1972, which is 800 meters long. This rock core became key to understanding Bermuda's origin. Scientists detected an unusual mineral composition, along with lead isotopes and some other heavy elements. These findings led to several hypotheses about Bermuda's origin. According to the most reasonable theory, Bermuda's formation was due to disturbances in magma flow, mixing with ancient tectonic plate fragments stored in the mantle's transition zone. This might sound complicated, but once you understand it, you will certainly be amazed. To better understand this, we need to go back 175 million years. The Atlantic Ocean was gradually forming. At that time, a supercontinent almost encompassed all of Earth's landmasses. As time passed, the plates that now form Africa, Europe, and the Americas began to split, creating vast ocean basins. During this process, many plate fragments sank into the mantle beneath the seabed, penetrating into the transition zone at depths of about 400 to 600 kilometers. Around 30 million years ago, disturbances in mantle flow caused these semi-molten fragments to rise to the surface again and mix with water, ultimately forming Bermuda and its unique geological structure. This process not only created the Bermuda Islands, but also formed similar volcanic islands in other parts of the world. It can be said that Bermuda, tens of millions of years ago, had already begun to exhibit its distinctive, unusual features. However, the mystery of the Bermuda Triangle is not only due to its geological structure. There are even more intriguing aspects beneath these waters. The Puerto Rico Trench is the deepest part of the Atlantic Ocean, reaching 8,180 meters. It is estimated that the depth may be even greater. The trench's slope is steeper on the side facing Puerto Rico, while the side facing the open ocean is more gradual. This 1,150-kilometer-long trench is one of the longest in the world, covering a total area of 186,000 square kilometers. Although science fiction writers often depict mysterious forces or unknown creatures lurking deep beneath the ocean, there is nothing mysterious or supernatural at the bottom of the Puerto Rico Trench. The trench bottom is filled with silt, volcanic ash, and fine-grained sand layers. Occasionally, deep-sea creatures are found dwelling within these sediments. At first glance, the seabed structure of the Bermuda Triangle seems unremarkable. It mainly consists of common sedimentary rocks like limestone, sandstone, and clay layers. In the Bermuda platform area, these sediment layers are about 1 to 2 kilometers thick, while near the coast of the Bahamas, they are 5 to 6 kilometers thick. The average accumulation rate of these sediments is about 6 millimeters per 150 years. In other words, over the past 120 to 130 million years, the seafloor in the triangle area has not changed much. However, this is only a surface phenomenon. The Bermuda Triangle has not only attracted adventurers, but also caught the attention of many renowned researchers. They are concerned about the safety of maritime navigation. There is actually a ticking time bomb hidden here, and when it will explode remains unknown. Scientists and amateurs alike are trying to find a balance between bold hypotheses and rigorous scientific methods to explain these strange ship disappearances. One striking theory involves the eruption of methane hydrates, a special form of natural gas. Scientific evidence suggests there are large deposits of methane hydrates on the continental shelf. The only question is, could the rapid release of these substances actually cause ships to sink? To verify this, an Australian research team conducted simulation experiments. The results were quite astonishing. When using small ship models in the experiment, the artificial gas eruptions easily caused the models to sink. This is because the density of the water drops sharply. It is speculated that intermittent methane eruptions could create bubble zones in the water, and this foamy water cannot provide enough buoyancy, causing ships to sink quickly and unexpectedly, unable to send a distress signal in time. The wreckage would then be swiftly carried away and scattered by the Gulf Stream, making these disappearance incidents difficult to trace. However, according to the same geological survey data, the Bermuda Triangle has not experienced any significant methane hydrate eruptions in the past 15,000 years. Nevertheless, this does not rule out the possibility of other explanations. No matter how exaggerated the mystery of the Bermuda Triangle may be, and no matter how far-fetched its secrets are, it has sparked the curiosity of an entire generation. Thank you all for watching. We hope you enjoyed today's scientific exploration. If you like our content, please remember to like, share, and subscribe to our channel to get the latest video updates as soon as possible. Leave a comment to share your thoughts and questions with us. Let's continue to explore the unknown world together. See you in the next episode.